One of the things is to look at the difference between experimental and theoretical probability. Again, a lot of times, what we do with probability, and if you've worked with probability in grade 8 or 9 or anything like that, likely you looked at theoretical probability. You said, questions like this. What's the probability of getting a 5 when you roll a die? 1 out of 6, right? What you're using is you're using that basic probability formula. This is the total number of outcomes, and this is what you would call the number of favorable outcomes. What does the word favorable mean? The ones you want, right? They use the word favorable here because those are the ones you want. It's the easiest thing to say without describing it with a lot of words. Essentially, the basic probability formula is favorable outcomes divided by total outcomes. For any situation, there's one big assumption you're making, though. What are you assuming here? Okay, you're assuming it's a 6-sided die in this particular case. That's a good thing to point out. What's the big assumption here about those 6 sides, though? They all have an equal chance, right? Assuming the outcomes are equally likely. Oops. Equally likely. Okay, assuming those things are equally likely. It may be that they're not equally likely, right? The die might not be a fair die, it might be rigged somehow to something come up more often. To calculate theoretical probabilities here, at some point we have to know something about the different outcomes. Okay, either they're equally likely or we're using the concept of equally likely here. If you wanted to check this experimentally, right? If you wanted to check this experimentally, you could simulate it. You could actually sit there and roll the die. We're not going to take the time to do that. We are going to simulate it with 2 things here. One is with this calculator. If you have this particular kind of calculator, usually on there, actually it's not on this one, sorry to say. It's on this one. Okay, if you have this kind of calculator, a TID3 or 84, you probably have this probability simulator thing on it. It allows you to simulate different things, tossing coins, rolling dice, and so on, right? We're going to roll dice. We're going to roll a single die. I am going to set it up so that if I just push roll, it's going to roll it once, and I have to push it again to roll it again, and so on. I don't want to push it, what did I say, 300 times here? I don't want to push the button 300 times. So I'm going to set it up so it's going to do a whole bunch at a time. I want 1 die. I want a 6-sided die. The graph is going to show the frequency, like how many times it's happened, not the probability that results, the experimental probability. 50 times is good, I think. Oh no, we want trial set. I think that's what I want. I think I want to put a 50 here, by the way. And then it'll roll it 50 times. Let's try. So if I hit roll here, I think it's going to go 50 times. Well, it'll show it once, and then it'll add 50 of them here. What do you expect is going to happen if we roll it more and more? Yeah, we expect that it's going to kind of level out at some point. We are assuming that this calculator is simulating it so that they're equally likely. Let's do that again. I know this is riveting watching this. I think the other ones are going to catch up. Now, if you're a betting person, people will tell you different things. A lot of people will tell you, if you were going to have to bet on one of those now, what would you bet on? Some people would say 1. Some people would say 4, right? Which would you bet on? 4, why? I'm just asking. I'm not criticizing anybody's choice. Because it hasn't come up that often, and so you think it should come up. Okay, that's good logic. What's the logic for picking 1? It might happen more often. You don't know. Like if something is consistently happening more often, maybe it is rigged, right? In sports, well, no. Think about it. In some situations, you don't even think about it. In this situation, I think most of you would be likely to say, "I'm going to pick 4 because it has happened. It's happened less, so it's probably going to happen more often to catch up, right?" I mean, at this point, the next roll could be anything, and we assume it has an equal chance. In sports, you're more likely to go with this, right? Like if a team has won more often, you're more likely to say, hey, that team is better. Let's bet on that team because they're better, right? They're likely to keep on winning. Anyways, the next roll could be anything. We're going to simulate it one other way here, too, online, because then we can just let it go in the background and do a whole bunch. Where's the one I was looking at? It's not actually dice, but it's something. It's the same thing here. We're going to have 6 little blocks in this, and it's going to randomly pick one at a time. All right. We're going to start this, and it's going to slowly make a graph of this, and we'll let it go for a while. Okay, this is how many draws that have happened. Looks like you should have been betting on 6, eh? So we're just going to let that run in the background, and we'll see what happens eventually. Okay? We have not had a 3. There's a 3. Okay, I'll put that away for a second. We'll go back to this. We want 300 here. You can see if you're right betting on 4 or 1. I don't know. We didn't write down the numbers actually, so it doesn't matter. But this is very exciting. Perhaps I'll pause this. I better turn it back on because it is just so darn exciting. This is the last one. We wouldn't want to miss that, especially if I can't even push the button properly. Go 4. Aren't we hoping for 5 here? Okay, and if you are using this, I think if you go across here, it tells you. This one is 51, 47, 61, 42, and this is the one we wanted, which is, this is probably not good, because it turned out to be exactly, this happened in my other class too, I don't know what the chances of that are. That the one that I had asked about here, how many times a 5 appeared, is 50, right? So we said the theoretical probability here was 1 out of 6. This is the theoretical probability. What's the experimental probability? Yeah. Experimental probability was, we had 50 times it came up as that, 300 in total. If you want to reduce that to lowest terms, it's 1 in 6. Is there any reason that these are going to be exactly the same every time? No, they aren't necessarily going to be. Actually, it's a pretty slim chance they're going to be exactly the same. If you do this exactly 300 times, the chance you're going to get exactly 50 is actually pretty low. It's probably going to be something else. It just happened to have worked out here, in this case, to be exactly that. All right? But you expect it to be closer. It's pretty unlikely it's going to be pretty far off there. What's that? This is the theoretical one right here. Theoretical one is just doing what we did up here, saying 1 outcome out of 6. This is what I'm saying is this would have been better if this had not turned out to be exactly 50. If you want the theoretical probability of what was one of the other ones there, how many times did it come up as this? Number of times it came up as a 4 is 42, right? So from our measurements, experimental probability of getting a 4, experimentally here was 42 out of 300, because that's what happened. Now, for this, you wouldn't ever measure it experimentally unless you wanted to try and see if this particular die you were using is rigged or not, because you would just assume that, you just assume that it's, that all 6 outcomes are equally likely, right? But in some things you're not able to do this, so you have to do this, all right? my grade 8s, I have them do something where they have a cup, like a plastic cup or a paper cup, that's bigger on one. Now that's upside down, right? And I ask them to drop it on the ground, and they measure how many times it lands each way. They come up with 3 different things. Actually, they come up with more. They say, well, it could hit the ground and break, or it could, it could just land on its little edge. And really, there's 3 things that could happen, right? We're ignoring all the incredible things that it could hit the ground and explode, right? That's probably not going to happen. We have to stop this.